Hello friends, welcome to sitza.com. Now in this video, we will learn about the stoichiometry. You all know that whenever we write down the reaction, we try to balance it. So like here this equation, it's not a balanced one. Hydrogen reacts with oxygen and forms the water, but it's not a balanced chemical equation. So when I balance it, it will be 2 times hydrogen and 2 times water here. Now this is a balanced equation. And the stoichiometric coefficients for this balanced equation will be 2 is to 1 and here it is 2. So 2, 1, 2, these are the stoichiometric coefficients for this equation. What is the stoichiometry? And what information we get from this stoichiometry? Stoichiometry is the study of the chemical reactions and the quantitative calculations related with it. So from this balanced equation, we got actually the ratio in which the reactants react and the ratio of the products also. So whenever we balance a particular equation, why we balance? Because from a balanced chemical equation, we get a lot of information. Number one, we get to know what is the ratio in which the reactants will react. And I can also write down the molar ratio also. You know, the molar ratio will be 2 is to 1 is to 2. Means 2 moles of hydrogen react with 1 mole of oxygen and form 2 moles of water. We can also write down the weight ratio. Weight ratio. So here 2 moles of hydrogen in terms of weight means how many grams? The molar mass of hydrogen is 2. So for 2 moles it will be 2 into 2, that is 4 grams, right? 2 moles of hydrogen, the weight is, in terms of weight, it is 4 grams. And 1 mole of O2 is 32 grams because that is the molar mass of O2. And what you get? We get 2 moles of the water. Water, 1 molecule, it has 18 molar mass and 2 more moles will be 2 times 18. That means we get 36 grams of water. So this is the molar ratio. 4 grams of hydrogen react with 32 grams of oxygen and you get 36 grams of the water. If you look at here, the weight of the reactants is also equal to the weight of products. So 32 plus 4, it is 36. The total weight of the reactants here is 36 grams and the product here is also 36 grams. So this is the law of conservation of mass also, right? Let's take another equation. Sulphur dioxide reacts with oxygen from sulphur trioxide. If you look at this balanced chemical equation, it says 2 molecules of sulphur dioxide react with 1 molecule of oxygen and you get 2 molecules of sulphur trioxide. So therefore, I can write down the molecular ratio here. So 2 molecules of sulphur dioxide react with 1 molecule of oxygen and they produce 2 molecules of sulphur trioxide. So I can also write down the molar ratio here. The molar ratio for the equation is, you can say 2 moles of sulphur dioxide, 2 moles, right? Here is molecule and here is the mole, right? 2 moles of sulphur dioxide react with 1 mole of oxygen and you get what? You get 2 moles of sulphur trioxide. We can also write down the weight ratio. Weight ratio. What is the weight ratio here? See, the 2 moles of sulphur trioxide in terms of weight is what? It is 2 times, we got the 2 moles times what is the molecular mass of, what is the molar mass of the sulphur trioxide, right? Sulphur dioxide. Sulphur dioxide, sulphur is 32. Oxygen here is 2 times 16. So 32 plus 32, it will be then 64. The molar mass of sulphur dioxide is 64. 64 times 2 This is 128 grams. So 128 grams of the sulfur dioxide react with 1 mole of oxygen, and 1 mole of oxygen in terms of weight is 32 grams, right? And what do you get? We get 2 moles of sulfur trioxide. So that means sulfur trioxide, its molecular mass, its molar mass will be, sulfur trioxide, its molar mass will be 32 is sulfur and oxygen is 16. So it is 48. So it is 80. So therefore you get what? 80 into 2, which is in terms of, which will be equal to 160 grams. So if you look at here, the reactants, so if you look at here, the weight of sulfur dioxide is 128 grams and the weight of oxygen is 32 grams. So that means 128 grams of sulfur dioxide react with 32 grams of oxygen and they produce 160 grams of sulfur trioxide. So if you look at the total weight of the reactants here, 128 plus 32, it is 160 grams, which is equal to the weight of the sulfur trioxide. So the law of conservation of mass also. Now let's do some numericals on the stoichiometry. What mass of calcium oxide will be formed on heating 50 grams of calcium carbonate? So let's write on the equation. The calcium carbonate, when you heat it and it decomposes into the calcium oxide plus carbon dioxide gas. Calcium carbonate is solid, calcium oxide is also the solid. So when you heat it, you get carbon dioxide. And now this is a balanced equation. The molar ratio is 1 mole of a calcium carbonate produces 1 mole of calcium oxide. And in terms of the weight, the molar mass of this calcium carbonate is calcium, it is 20. So the calcium, let's calculate the molar mass of the calcium carbonate. It will be the 40 plus 12 plus 3 times 16, right? Which is equal to 80. So 1 mole of, so that means calcium carbonate is 80 grams because that is the molar mass. Calcium oxide, the molar mass of the calcium oxide is, calcium is 20 and this is 36. So the calcium oxide, its molar mass is 36. Carbon dioxide, the molar mass is 44 grams. So from 1 mole of a calcium carbonate, you get 1 mole of calcium oxide and 1 mole of a carbon dioxide, which in terms of weight is 80 grams of calcium carbonate decomposes and produces 36 grams of the calcium oxide and the 44 grams of the carbon dioxide. So from the balanced chemical equation, this is the from this balanced chemical equation, I get 80 grams of, from 80 grams of calcium carbonate produce how much? They produce the calcium oxide of 36 grams, right? So from 1 gram of calcium carbonate you get 36 by 80 grams of the calcium oxide, and I need to check it for the 50 grams of calcium carbonate. So therefore from the 50 grams of calcium carbonate, right, 50 grams of the calcium carbonate, I'll get how much of calcium oxide? It is 36 by 80 times what? Times 50, right? This will be the weight of calcium oxide. So that will be equal to 22.5 grams of calcium oxide. That means from 50 grams of calcium carbonate we get 22.5 grams of calcium oxide. Now here is another equation, another question. We have to find the weight of a sulfur trioxide produced from 2.56 grams of sulfur dioxide. So here's the balanced equation, and the molar ratio here is 2 moles of sulfur dioxide react with 1 mole of oxygen and you get 2 moles of sulfur trioxide. That is the molar ratio, right? This is the molar ratio here. And what will be the weight ratio then? The weight ratio here from this equation, from this balanced equation, is 2 times 64, which is 128 grams, right? So 128 grams of sulfur trioxide will react with a 1 mole of oxygen, which in terms of weight is 32 grams, and you get 2 moles of sulfur trioxide, which is 2 times the sulfur trioxide is 80, the molar mass of SO3 is 80, so therefore it will be 160 grams. So from the balanced chemical equation, what we get? We got that 128 grams of sulfur dioxide produce 160 grams of the sulfur trioxide, right? So from 128 grams of sulfur dioxide, we get 160 grams of sulfur trioxide. So I'll relate the two, because we need to find the weight of sulfur trioxide from the 2.56 grams of sulfur dioxide. Sulfur dioxide, and when I relate the sulfur dioxide and the sulfur trioxide in terms of weight, 128 grams of sulfur dioxide produces 160 grams of sulfur trioxide. So let's calculate for the 1 gram. So the 1 gram of sulfur dioxide will be equal to 160 by 128 grams of sulfur trioxide, and I need to check it for 2.5, so therefore 2.56 grams of sulfur dioxide will produce how much? 160 by 128 times 2.56 grams, right? Which is equal to 3.2 grams of sulfur trioxide, right? That means from 2.56 grams of the sulfur dioxide, we get 3.2 grams of sulfur trioxide, right? Hope you got the concept. Thanks for watching the video. Bye for now.